let's just start with the absolute basics. How do you guys even define indoor air quality?
Well, indoor air quality is a measurement of the comfort level and healthiness of the air inside. It's measured using some variables: temperature, relative humidity, CO2 levels, particle count, and VOC levels.
And then what would you consider to be good or bad indoor air quality?
Sure. So ideally, you want indoor air quality that supports comfort. The people inside want to be comfortable and support their long-term and short-term health and their productivity. So there's ranges for all of these variables. The temperature is really, this is probably the variable we're most used to. In the winter, where it's probably around 68 degrees, plus or minus 5 degrees. And in the summer, it's probably around 72 degrees, plus or minus 5 degrees, based off personal preferences. And then on the relative humidity side, that's another metric that we're kind of used to. The goal is, not too dry and not too wet. So the range is usually 40% in the winter up to 55% in the summer. Then we go over to CO2, and CO2 is a little bit more subtle. You can kind of sense high CO2 levels because it makes you feel drowsy or sluggish. Outside, CO2 levels are about 400 or 420 parts per million. And indoors, you should try and keep it under 1,200 and ideally under 800 parts per million. We can start sensing it at about 3,000 parts per million. And when you're on an airplane and you're getting drowsy, that's the feeling of high CO2 levels. Or when you're in a meeting in the afternoon and there's a lot of people in a small room and it's feeling, you're having a hard time staying awake, that's high CO2 levels also. Then we go over to PM count or particle count. The measurement we use is PM 2.5, which is a measurement of ultrafine particles. And the 2.5 stands for 2.5 microns or smaller in diameter. These are the particle size we really care about because our body's normal systems can't handle these types of small particles. We can handle PM 10 and larger, 10 microns, which is kind of like pollen and dust and dander. But when you get down to PM 2.5 and smaller, these particles get into our bloodstream through our lungs, directly into the blood, and end up giving lung, heart, and brain issues over time. So PM is definitely the particulate matter count in the air, and higher is worse. Ideally, we want as low as possible.
And then about the PM particulate matter, is there, are you trying to measure specific kinds of particles, or is it just measuring all the particles of a certain size?
So we're measuring all particles of a certain size, 2.5 microns or smaller, and the measurement is micrograms per meter cubed. So you're measuring the amount of weight there is in a cubic meter of air.
Which is, I would imagine, a measure of density, essentially?
Yeah, that's a good way of looking at it.